Hello everyone, welcome to the 8085 practical series. In today's session, we'll study about packing and unpacking of BCD digits. So we'll be doing two programs. The first is the packing the unpacked BCD. So in this particular program, what the description is given: pack the two unpacked BCD numbers stored in memory locations 4200H and 4201H and store result in memory location 4300. Assume the least significant digit is stored at 4200. So in this above case, we have two memory location 4200 and 4201 and the data is 07 and 04 respectively. So this is actually unpacked BCD. What we have to do is we need to pack this number. So this 07 and 04, when they are packed together, we have 47. So here it is given the least significant bit is at 4200. So 7 is at the least significant and 4 is at the highest, is the most significant digit. So this is what we have to perform. So 0704, this is the unpacked BCD. It must be converted to 47. This is the packed BCD data. So let us first see the program and then execute on the simulator. So this is the required 8085 code. Starting from 8000, we have LDA 4200, then move B comma, then LDA. So this is the required code. This is the hex code. Now let us execute this and understand each and every instruction on the simulator. Then it will be more easier to understand, because in that case we are executing each and every instruction and getting the output. So we are into the simulator now, and this is the required code. I have already entered the code, and this is the data. At 4200 we have 07 and 4201 we have 04. So let us execute stepwise. So with the first step, the data from 420, so LDA 4200, it transfers the data 07 from memory location 4200 to register A. So we have this 07 at 4200, it gets transferred into register A. Next, we transfer this content from A to B. So this 07 is the lower digit, BCD digit, and we transfer it to B from A. Then LDA 4201. Now in this case, we transfer the contents from 4201 to register A. So this is the higher BCD digit 04, and the lower digit is now in B and the higher is in A. Now next, what we do is we are doing this RRC 4 times. So what this instruction will do, RRC is rotate accumulator right. So this instruction rotates the contents of register A by 1 bit towards right. So if we rotate this 4 times, so what will happen is by doing this RRC 4 times, this 404 will become 40. Okay, so with the first RRC, the data changes to 02. With the next, it becomes 01, then 80, then 40. This is what is required. So we have to, why are we doing this RRC 4 times? Because we want to actually shift this 4 to the and 0 to the right. Okay, so this is what we have achieved. So 04 becomes 40. Okay, now A contains 40 and B contains 07. So we need to combine them. So we need to make this 40 and 07 as 47. So with the next step, what we do is we are doing ORAB. So ORAB actually ORs the contents of register A with B. So A contains 40 and B contains 07. When we OR, we get 47. This is what is we are getting, 47. Okay. Now this is the required output. So this is now packed. So the unpacked was 0704, the packed is 47, and we need to store this at 4300. So next step, STA 4300, it will store the content of register A to memory location 4300. So we get this 47. So this is the required output. So this 0704 they convert. These two are the unpacked, and this 47 is the packed BCD. So this is how we execute the first program. Now let's go to the second one. So the next part is unpacking the packed BCD. So here we are given a 2-digit BCD number is stored in memory location 4200. So this is the 2-digit packed BCD digit 76 is stored at 4200. So we need to unpack the BCD number and store the 2 digits in memory locations 4300 and 4301. such that the memory location 4300 will have the lower BCD digit. So this is the packed data 76. We need to unpack it so that it becomes 07 and 06, and 06 must be stored in 4300 and 07 must be stored in 4301. So let us see how we can do this. So we are now into the simulator, and I've entered this code, and at 4200 I have saved this number 76. So let us do this step by step. So with the first step, LDA 4200, the data 76 which is at 4200, it gets stored in register A. Now in the next step we do ANI. ANI is and immediate 0F. So now we are actually masking the higher order bits. So the data is of 8 bits, so we are masking the 4 bits, the higher order 4 bits. So we only get out of this 76. So this 7 is of 4 bits and this 6 is of 4 bits. So we are masking this 7. So we only get 06. So this 06. So here our half job is done. So 76 we have recovered 06. So with the next step, we store this at 4300 by using the instruction STA. So STA store accumulate direct. It stores the data from register A to the memory location. So this is done. Now we need to get 07 also. So with the next step, again what we do is we transfer the content from the memory location 420, that is 76, into register A. Then here we do ANI F0. So now here we are masking the lower order 4 bits, low 4 bits. So 76, when we and immediate with F0, we only get 70. So now 6 is now deleted, we only have 70. But this 70 has to be converted to 07. Okay. So in the previous program, what we did was we executed 4 RRCs. So here also we will do the same thing. So with the first RC, the data changes. With the second again changes. With the third again, and the fourth we get this 07. So 70 becomes 07 with 4 RCs. So rotate right accumulator. Okay. Now this is what is our output is 07. Now this is to be stored at 4301. So with the next step, this gets stored at 4301. So this 76 was the packed BCD. We have unpacked it with 06 at the 4300 and 07 at 4301, and this is the halt instruction. So that's how we do the packing and unpacking operation of BCD digits with 8085. So that's all for this session. Thanks for watching.